Hello, dear aspirants. This is Dr. Sourav sir's class. We are solving the National Boards of Higher Mathematics question papers. This is previous year question from the year of 2014. So the question says us, let Pn denote the vector space of all polynomials in one variable with real coefficients and of degree less than equals to n. So that means our Pn is what? I am gonna write the vector space as our Pn is a0 plus a1x plus a2x square dot that is to our an x to the power n, where our ai belongs to R and my n is what? My n is equals to 0 1 dot. This is my set. Yeah, this is my the vector space. So equipped with the standard basis 1 x and x to the power n, we have written in our question in our this form. So now they have defined a linear transformation which is our t, which goes to P2 to from P2 to P3. Yeah. So what is our no, so the T of P of X is my integration of 0 to x pt dt. After that there is my P dash x plus P2. So we have to determine the dimension of the kernel of T. Okay, so firstly I am gonna write the basis of my P2. So what is my P2? P2 is equals to A0 plus A1x plus my A2x square, where our A0, A1 and A2 belongs to R. And what is my P3? P3 is equals to A0 plus A1x plus A2x square plus A3x cube, where our A0, A1, A2 and A3 belongs to R. Yeah. So now, so where our T1 goes to, our T1 goes to 0 to x 1 dt, that means dt, plus the derivative of 1 is my 1. So this is 0 plus T of 1 will be my 1, and so my thing is x minus 0 plus 0 plus 1. So this is my x plus 1. So my t of 1 goes to x plus 1. Now I am gonna find my t of x, that is 0 to x. This is my t dt plus this is the derivative of x with respect to x is 1 and this is plus 2. So my t dt will be t square by 2 0 to x plus 3. So this is my x square by 2 plus 3. So now I am gonna find my t of x square. So by the same thing we can get this. Yeah, so our derivative of x square with respect to x is my 2x plus x square, and they have told me to find the P2. So P2 is my 4. So I have got my t cube by 3, 0 to x plus 2x plus 4. So that will be x cube by 3 plus t plus 2x plus 4. Yeah. So now we have to write the matrix which is associated to t. So we can write this by this t. I want to write it in another color so that will be easy to visualize. So t of a is what? The first, so t of 1 goes to my x plus 1. So that is my, so the matrix will be, yeah, that is 1, 3, 4. Then the 1 terms, so there we will get 1, 0 and there is 2, so 2. Then we have to find the x square terms. This is here, so this is my 0, half, 0, and last is for the x cube. So we got this thing. This is my matrix which is associated to our transformation, so our linear transformation. So we have to find the rank of it. So rank of it is what? We can easily see that, but I want to write something. By the elementary row operation we can say that r1 less minus 6 r2, sorry, I want to write r3. Then we will get 1 0 4 1 0 2 0 half 0 and 0 0 1 by 3. On the second note we want to write r1 minus 12 r4. Then 1 0 0 1 0 2, that will be my 0 half 0 0 0 1 by 3. So again what can we do? We can do r2 minus, that will be 2 into 3 by 2 r4. Then we will get this thing. Yeah. After that we can write this to r1 minus r2. Then we will get, yeah, this row will be my 0 0 0 1 0 0 0 half 0 and 0 0 1 by 3. So the pivotal positions are here. So the rank of the matrix is, I want to write it as this manner. So rank of this is my r equals to 3. So now I have to find the kernel, no? By the rank nullity theorem, I want to write it by this color. Yeah. So by our, yeah, rank nullity, we can say that dimension of P2 is equals to my dimension of kernel of T plus it will be dimension of another hand we can say that uh, yeah, rank of T. So our rank of T is 3, dimension of P2 is 3. We know that as there are the basis elements are 1 x and x square, so the dimension of P2 is 3, and here we will have the dimension of kernel of T plus our rank we got 3. So our dimension of kernel of T, that means the nullity of T, is equals to 0. This is the required thing for the question. Hope you understood. Thank you guys.